Well, if they don't turn the lights up a little, this is going to feel a little off. So today will be our last day going through a section of the book. We'll do 7.4. On Wednesday, we will have our in-class review. I've already uploaded to Scholar the sample questions we're going to discuss in class on Wednesday. There is a tutor-led session available. I believe it's tomorrow night. I've sent you the link by Scholar about a week or so ago. Perhaps I'll look for it tonight and send it again if I'm feeling generous. The final exam is this Friday in this room at, oh wait, no, I'm sorry, that's incorrect. The final exam is next Wednesday in this room at 11 a.m. All right. Serves me right. The final PowerPoint I wanted to do is eluding me. Let's see. Yeah. All right. Let me look for it one more time. Oh, I know where I can find it. There you go. All right. So we are down to our last new topic. And the final topic we are going to talk about that builds on everything that we've gone over to this point are the more complex refutations. Now, you should remember, and you should have written down in your notes very clearly, the difference between a proof and a refutation is this. A proof seeks to demonstrate that a certain claim does follow from a certain set of premises, and thus the argument is valid. A refutation intends the opposite. It intends to show that a certain claim does not follow from a certain set of given premises in an argument, and therefore the argument is invalid. If you remember that, that will give you a leg up um, in, uh, in the Chapter 7 related questions. So now we're going to talk about more difficult versions of refutations. So far, the refutations we've looked at did not require multiple assumptions. So they were doable with the S&I rules and the basic starting assumption of the opposite of the intended conclusion. So now we are going to do versions of refutations that require multiple assumptions. So we're going to do the same things that we've done in the past. We're going to try to set the truth values of the premises to true and the conclusion to false to show that the argument is in fact invalid. And we're going to seek to find assumptions for the letter values compatible with the premise values as invalid. So for example, let's take a look at this example from 7.4. We're going to work with the assumptions. If A, then both F and P, and if not A, then N. Those are our two premises. From that, we're going to show that P does not follow from those two claims. And we will ultimately find that, here's a preview of where we're going to end up. We're going to show that when A is false and N is true and P is false, that will give us an invalid set of values here. But let's take you through the step-by-step of it. So again, this is a refutation, and with all the Chapter 7 style problems, the proofs and the refutations, we do what first? Assume the opposite of the conclusion. Thank you. 5 cents for the young man in the front row. So we start by assuming the opposite of the conclusion, and that's step 3. But then if you look at the situation we have with 1, 2, and 3, 1 and 2, there are no S rules for basic arrows. So you either need an A or a not A to match the left side of the arrows in 1 and 2, or you need the opposite of what's on the right. And we don't have that. What can we do? We should try an assumption that will let us do an inference. So we're going to assume not A, because I'm looking up at 2, and if I plug not A into 2, then that will let me make an inference about N. So I want to assume not A. So in step 4, we assume not A. It is our second nested assumption. Not A, it allows us to use an I rule with line 2. If not A, then N. Plug the not A in, we get N. At that point, we ask, are we done? Yes, we are, because we've used 2 in an inference. 3 through 5 are simples, and statement 1 is what is called broken. We have the opposite of the left half of statement 1, and we yet can't do an inference. Now, we kind of have a problem here, though. You see the problem? What value do we need for F? We haven't quite gotten there yet. So we're done. When we've used all the S&I rules, when each complex statement has been used, blocked off because it's in a subproof, or broken because we already possess one side. So here's what we do with F. The truth is, you can plug in either value for F, and it will still be an invalid argument. And that's because premise 1 is true no matter what the F is. So you don't need to do an assumption for F. All right. Let's give you this one. Did you do this one in the homework last night? How many of you have already done this refutation? All right, most of you have not. I want to give you 5 minutes, and I want you to work this refutation here and now. I want you to see where we stand with our advanced refutation skills. All right, well, shall we try to work this together? All right. Step one, as has already been said today, first thing we always do is assume the opposite of the intended conclusion. So the intended conclusion here is if E, then C. So the opposite of the intended conclusion is it is not the case of if E, then C. Then we will do whatever S&I rules we can. And we can't do anything with 1, 2, and 3, but 4 is a negated conditional, and we have an S rule for it. We can use NIF. That will allow us to infer out the match of what appears on the left and the opposite of what appears on the right. So step 4 is an assumption. Step 5 and 6 are both from 4. Negated if-then statements, or as I like to call it, NIF. All right, then we look at this again. We've used 4, then we go back to 1, 2, and 3, especially looking at 5 and 6, seeing if there's a possible inference, and there's not. Now I look at 2 in particular, and I note that 6 already breaks 2. So I'm not going to need to do something with 2. I'm not going to need to do something with 4. I need to assume something that goes with 1 and something that goes with 3. Now, the way the strategy the book proposes, the Gensler in the book in this section, he prefers to assume things that break premises rather than do inferences. So if we wanted to break a premise, let's look at premise 1. What is something we could assume to break premise 1 so that we could not do an inference with it? We could assume not A. And this is an assumption. Now, you don't have to put this, but you might say why you're doing it, at least for your own self, and it might communicate to me that you know what you're doing. That breaks line 1. So that finishes what we can do with line 1. So then we just need something for line 3. What could we do for line 3? We'll make another assumption that breaks line 3. And we can just do not F. Then we use RAA to check our work, make sure this has given us an invalid argument. So the values we have to plug in are true for E, false for C, false for A, false for F, and then nothing for the remainders. So true for E, false for C, false for A, false for F. And when we do that, premise 1 is true because the left side of the arrow is true. Premise 2 is true because the left side of the arrow is true. Premise 3 is true because the left side of the arrow is true. But the conclusion is false because the left side is true while the right side is false. Now note, there were more than one correct way to do this. Did anybody else do anything significantly different? So on like line 7. Yeah, I mean, you really should do the S rule on line 4 before you start making extra assumptions. Okay, so well, after you do line 4, you need to do the S rule on line 4, and you get the E and the not C out of line 4. Because line 4 is a negated condition. So you don't want to assume what? Right, well, again, line 5 isn't an assumption, it's an inference, or it's an S rule. So line 5 and 6 aren't assumptions. That's something that that almost every correct version is going to have to do this S rule at some point. So it's just a question of whether you want to do it now or later. And the smart thing is to do it now, so you don't make unnecessary assumptions. But here, let me suggest a route that that we didn't do here. What you could do is, if you're like me, I don't really like all this breaking premises business that Gensler really likes. We went through all the trouble to learn those S&I rules. I kind of feel like we should do some S&I inferences when we can, right? So instead of all this, it would be perfectly correct, after step 6, to make an assumption that lets us do an inference. I would like to do step 7, a nested assumption. I would like to do the claim that A is true, which would let me do inference 8, that B is true, from 1 and 7, NP error rule. And the nice thing about that is that gets us a value for B. Now, you don't have to do that, but you can. And frankly, like I said, we learned those S&I rules for a reason. Now, we get into trouble, though, if we just assume F here, because if we assume F here, we're going to end up with C being true, and that's going to start to cause some problems. So it is probably smarter just to break the left side of 3. But all that to say, there are more than one correct way. There is more than one correct way to do this. Now here's something funny. Let's say we did want, let's say you were really stuck on doing F as an assumption here. You could do F as an assumption. And here's what you would get. You would then do the inference in 3. You would get both C and D is true from 1 and 9. I'm sorry, not 1 and 9, 3 and 9. And once you got C and D is true, you'd use the AND rule on C and D. But because you've got C, you have a contradiction with 6. And then what you would do is you would block this off. And step 13 would give you the opposite of the most recent assumption. And you would still end up with not F from 9, because 6 and 11 contradict. So, and that's why Gensler prefers to break premises rather than do inferences, because you get a lot more extra things like this that get complicated and hard to follow if you start doing inferences. You would still consider C false because your true C is in the subproof that resulted in the contradiction. So you get your the values that you use not from anything that leads to a contradiction. Because anything that leads to a contradiction is a unusable subproof. All right, how are we doing with these advanced refutations? Hard to tell you quite. That either means you've all mastered it already, or you're all lost and are ashamed to admit it. Or what I really fear is everyone in the room kind of gets it, but everyone at home is utterly lost because they're half asleep and they're going to be blindsided by the sun fire. Should we do one more? Yeah, we should. All right. All right, we did that. All right, let's talk about this one together. Step 1, either A or is not the case of if B, then C. Premise 2, if D, then if A, then B. Therefore, we will prove that it does not follow. We will refute that it follows. If C, then it is not the case of either D or A. Step one, we assume the opposite of the conclusion. So again, we slap a negation outside the outermost parenthesis. Now, again, this is where knowing how to use these extended inferences is important. You need to be able to recognize that this is an arrow statement and that negated arrow gets us the match of what's on the left of the arrow, gets us an inference of C, and it gets us the opposite of what's on the right of the arrow. We get D or A. Once we're there with 1 through 5, then we're stuck and we have to make extra contradictions. And let's use Gensler's strategy because it's simpler. Let's just try breaking things. So we'll look at premise 1, and if we assume A, that will break A or. It is not the case if B, then C. So we'll assume A. That also incidentally breaks number 5. Then we'll assume not D to break 2. Then we've got 1 broken, 2 broken, 3 has been used, and 5 is broken. Then we're done. Then we plug in the values. A is true, C is true, D is false. Turns out it doesn't actually matter what B is, so this will be invalid whether B is true or B is false. I don't know, looking at section 7.4a, is there anyone there that you'd like to see me do? Yes. When you have an or, you need the opposite of either half to use the or. So when you assume A, you have one of the halves, or the reverse one of the halves, but you have the match one of the halves, but you can't do an inference. So A is broken because we've assumed A, which means we can't get the opposite of A. So therefore A is broken, therefore 1 is broken. Yes? Sure, let's do number 4. Number 4 says, is that the one premise one? Yeah, got it. Number 4 says, it is not the case of both A and B. Therefore, let's refute that it is not the case of A if and only if B. All right, well, all right, so first thing we do in step 2 is we make an extra assumption. We're going to make the assumption of A if and only if B. So the first thing we do is we drop that negation off the intended conclusion. Then we look at 1. We'll remember that you need an I rule for 1. You need the negated and a match of one of the two halves, so we can't do an inference with that. But we do have an S rule for triple bar. And the S rule for triple bar gets us 2 conditionals. It gets us if A, then B, and it gets us if B, then A. So at that point, we've used 2, so we don't have to worry about it anymore. Now, we then look back up at 1 and ask, have I added anything in 3 and 4 that lets me do an inference with 1? The answer is still no. I look at 3 and 4. These also I can't do anything with because I either need an a B, a not B, or not A. So I can't do anything with them. So I'm going to make another assumption. And here I'm going to assume let's assume A. And once I've got A, I can do inference with line 1. A and not both A and B gets me not B with line 1. And I put a little check mark next to that. Then, I'm going to do, then this is rather weird because I do have to do an inference with 3 or 4 because they're not broken. I'm going to plug that A into 3, and I'm going to get B. 3 and 5. That's the arrow rule. 6 and 7 contradict, which means I block this off and infer out the opposite of the most recent assumption, which is not A, from 5 between 7 and 8 contradicting. Now, at that point, let me look. All right, now at that point, I think I've got to do it again because I've got the not A. This is blocked off. I can't do an inference with that, but I can do an inference with 4 now. So, yeah, I see why you want to see this one done. You can get the not B from 4 and 8. And then I think we're done. Yeah, we are done. Good. Because I can't do an inference with 1. I could do, I've got, I could do an inference with 3, but all I would get is another not A by plugging in that not B. And I've already done an inference with, oh, and 4 is broken on both sides. Oh, I guess I could do not A, but yeah. So yeah, you're left with this. So you've got false for A and B, and then we'll plug it in and see if it works. So A and B both can't be true, and that statement is true because they're both false. And this says A and B can't match, which is false because they do match. Therefore, the argument is invalid. Do you end up with something like that?
Yeah, I just didn't know what assumptions to make after A and B.
I mean, honestly, there might have been an easier way to do it. But I think if you assume any of the 4 things, you end up with something like this. Maybe if you assume a negation, maybe you get to the end quicker. Because if you have a negation, then you can't do an inference. Actually, a quicker way. You see, this is a case where what I did was correct, but what I did was longer than what we really needed. So if in step 5, we had instead assumed not B, I could plug that in with 3 and get not A, and that would be from 3 and 5 an arrow rule. And then at that point, I can't do an inference with 1, so it's broken. I've used 3, so I don't need to do that again. We've already used 2 to get these errors in the first place. And then, I mean, there's no point in using 6 with 4 because I would just get not B again. So that's redundant. So yeah, then we end up with not B and not A, and we do it a little quicker. So a good example of sometimes what you do is correct, but it's unnecessarily wrong, which is what my problem is. All right, let me show you one more thing. I want to draw your attention to a kind of problem that will appear on the final, and we haven't talked about this as much as I would like. By the way, this document has been uploaded to your Scholar, so I recommend that you look at it because we'll talk about this a little more in depth on Wednesday. So one of the skills that you should have learned by this point, although we've had no exercises directly on it, is how to build deductively sound arguments. And here I've given you the premises that we've been using for several of the problems, or at least premises that are similar to the problems from 7.1 through 7.4. So at this point, you should be good enough on your own that I should be able to propose several premises to you, and you should be able to spot which ones can go together to build a deductively valid argument. So here are premises much like the ones in 7.1 examples. Either the butler or the maid committed the crime. If the maid did it, she didn't have an alibi. 75% of all crimes are committed by the butler. At least Hollywood would have us think. If the butler did it, he didn't have an alibi, but the butler had an alibi. So we should be able to look at these and spot possible deductively valid inferences. First thing you should always do is, for deductively valid inferences, you should avoid anything using probability. Probability is an inductive tool, and that's not going to help you build a deductively sound argument. Then you need to just recognize what kind of statement each of these is. This is an or statement. This is an if-then conditional. This is an if-then conditional. And this is a simple. Probably the easiest thing to do is, once you've eliminated the probability argument, probably the easiest thing to do is just to quickly translate the different statements to see if there's an obvious inference. I did a minor thing I shouldn't have done there. I translated the maid having an alibi and the butler having an alibi as the same constant, which I should not have done. There we go. And then, once you've translated, you look at it and you ask, are there any inferences I can do? And lo and behold, here's one. From the combination of, if the butler did it, he wouldn't have an alibi, but the butler had an alibi, you can do the inference that the butler did not do it. Easy peasy. But a way that I presented these sorts of problems that you have not seen before. Yes?
Would you not be very premise?
Nope. So when you're asked to build, so this is the skill you use when you write your own papers. And that's why this is part of the class, is We want you to walk away with this. When you do research for other classes, you're gathering premises. And your goal in a paper is to write a 10 or 15-page version of one of these arguments. But you need to start with what's the argument going to look like, and you need to build ideas that go together properly. So often, the papers I don't like, they often don't have a thesis. Often I like to say, here are 10 disconnected facts about butlers. And, I'm going to investigate butlers in this paper. That is not a good college level argumentative paper. You want to argue that the butler did it, that the butler didn't do it, that butlers are often unfairly stereotyped because of their low social standing, or something like this, or the anti-male bias in our judicial system. Have fun with it. But the point here, of course, is it all boils down to logic at the end of the day. All right, thank you very much. We will see you for our in-class review on Wednesday. Good luck. Stay healthy, stay safe, get vaccinated, have an awesome summer. How you doing in your other classes? You ready for everything?
We're getting there slowly.
Now, I hope that wasn't a little cough I heard there.
No, it's allergies. We're getting allergies this morning.
Oh, I hate allergies. I remember when the pandemic started, the first 2 months, every morning I'd wake up and say, am I dying? No, I just have an allergy.
That's just every time I have allergies.
Very annoying, but such is life sometimes. See you Wednesday.